HVAC efficiency is largely dependent upon the conditioned air being moved to the living space without loss of conditioned air or intrusion of unconditioned air. The most effective way to verify the loss or intrusion is by testing the tightness of the ducts using duct leakage testing equipment, as we'll show you now.
The total leakage test measures all leaks in the duct system, both leaks in the ducts that are running outside of the house, as well as leaks in the ducts that are located inside the house. The basic concept of the total leakage test is really quite simple. We're going to connect the duct blaster fan up to the duct system, typically at a central return. We're then going to tape off all the remaining supply and return registers. We will then blow air into the duct system using the duct blaster fan and pressurize the duct system to a test pressure of 25 pascals, which is equivalent to 0.1 inches of water column. The airflow needed from the duct blaster fan to achieve our test pressure of 25 pascals is the measured total leakage rate. Before we begin to set up for the test, let's familiarize ourselves with the various components of the duct blaster system. First, we have the duct blaster fan. The fan provides the airflow needed to pressurize the duct system. Connected to the back end of the fan is 12 feet of 10-inch diameter flexible extension duct. This flex duct is used to direct the airflow from the fan into the duct system. On the front side of the fan, or the fan inlet, you will see a stainless steel flow sensor mounted on the end of the motor. This flow sensor is used to measure the airflow going through the duct blaster fan. Also included with the fan are 3 flow rings, which attach to the inlet and allow the fan to accurately measure a wide range of duct leakage rates. Finally, the duct blaster system includes the DG700 digital pressure gauge. The DG700 gauge is used to simultaneously measure both the pressure in the duct system and the airflow going through the duct blaster fan. Now let's get started setting up the duct blaster system for the test. The first thing we need to do is connect the duct blaster fan to the duct system. This is typically done at either a central return or the air handler cabinet using the blower compartment access panel. For this test, we're going to use the central return as the location to connect the duct blaster fan. Check the central return to see if there's a filter mounted on the filter grill on the back side, and if there is, remove it. In addition, if there are filters located at the air handler itself, these will also need to be removed before we can begin. To connect the flexible extension duct to the central return, first take the square transition piece from the end of the flex duct and carefully tape it onto the center of the central return. Once you've done this, tape off the remaining opening on the return grill. Now slide the open end of the flex duct fully over the round collar of the square transition piece and tightly secure the flex duct using the black Velcro strap attached to the end of the flex duct. We now need to prepare the duct system and the house for the test. First, adjust the HVAC system controls so that the air handler fan does not turn on. Go around and turn off any exhaust fans, vented dryers, ventilation system, and room air conditioners. You will also need to open a door or window between the house and outside to prevent changes in house pressure when the duct blaster fan is running. The next step is to seal off the remaining supply and return registers. This is typically done using masking tape and paper, or an adhesive-backed film called duct mask. We now need to choose a location to measure pressure in the duct system. The most common location to measure duct pressure is a supply register near where the duct blaster fan has been installed. Other locations can include the supply plenum or a main trunk line in the supply duct system. For this test, we're going to use a supply register. First, insert the 6-inch straight stainless steel probe into one end of the green tubing provided with the duct blaster system. Now push the probe through the tape or duct mask that is sealing the register. Make sure that the end of the probe is not blocked off. Now we need to make the tubing connections to the DG700 gauge. First, take the open end of the green tubing that was inserted into the supply register and attach that to the Channel A input tap. Now take the 10-foot section of red tubing and attach one end to the Channel B input tap and the other end of the red tubing to the brass pressure tap located on the middle of the duct blaster fan housing. Once we've made the tubing connections, it's time to connect the speed controller to the fan. First, line up the female connector from the controller with the 3 metal pins on the fan receptacle and push the connector completely onto the pins. Now secure the connector to the fan using the locking ring on the connector. The remaining power cord should be plugged into the power outlet. Make sure the controller is off before plugging in the power cord. The next step is to choose and install the flow ring which you think best matches the needed fan flow for your test. If you suspect you're testing an extremely leaky duct system, don't install a flow ring at all. Leave the fan in the open configuration. As the duct systems you test get tighter, you will need to install flow rings with a smaller and smaller opening. Flow ring number 3, with the smallest opening, is used on the tightest duct systems. When in doubt, start with flow ring 1 or flow ring 2. Don't worry if you make the wrong choice. You can change the flow ring during the middle of the test. It's now time to set up the DG700 pressure gauge. Turn the gauge on using the on-off button. When first turned on, the DG700 gauge is automatically placed in the pressure mode. In this mode, the gauge displays the differential pressure from channel A on the left side of the display and the differential pressure from channel B on the right side of the display. The current selected mode is shown in the bottom left-hand corner of the gauge display. The DG700 gauge has a specialized mode for conducting a total duct leakage test. To put the gauge in this mode, press the mode button 3 times. The mode indicator on the display should now read PRFL at 25. In this mode, channel A is used to measure the duct pressure created by the duct blaster fan, and channel B is used to display estimated total duct leakage at a test pressure of 25 pascals. We now need to enter into the gauge the test device we are using and the configuration of that test device. For this test, we are using the Series B Minneapolis Duct Blaster fan. Find the device key and press it 4 times. The device indicator in the upper left-hand corner of the display should now read DBB for Duct Blaster Series B. The configuration of the fan, in other words, which flow ring is installed, is entered using the Config button. Press this button until the indicated configuration, shown on the upper right-hand corner of the display, matches the flow ring you have installed on the fan. For example, if no flow ring is installed on the fan, the config indicator should say Open. If ring 1 is installed, the indicator should say A1. If ring 2 is installed, it should say B2. And if ring 3 is installed, the indicator should say C3. We're now ready to conduct the test. Turn on the duct blaster fan by slowly turning the fan control clockwise. As the fan speed increases, the duct pressure displayed on channel A should also increase. Continue to increase the fan speed until the duct pressure, shown on channel A, is close to 25 pascals. Somewhere between 20 and 30 is good. Don't waste time adjusting the fan to a test pressure of exactly 25 pascals. This is unnecessary because the specialized pressure flow at 25 mode will automatically adjust the measured total leakage rate to the test pressure. Once you're done adjusting the fan, channel B will now be displaying the measured total duct leakage rate in CFM. In this demonstration, the total duct leakage measurement is 86 CFM, using ring 2 on the duct blaster fan. You should write the leakage measurement down for later entry into program forms or software. Once you've determined the total leakage rate for the duct system, you can now estimate the leakage area of the duct system in square inches. This is done by pressing the Units button 3 times while the duct blaster system continues to operate. In this demonstration, the gauge indicates that the duct system has a leakage area of approximately 16 square inches. The leakage area is a useful way to visualize the physical size of all the leaks in the duct system being tested. Finally, one of the most effective ways to find leaks in the duct system is to use a theatrical fog machine while pressurizing the ducts. With the registers and grills temporarily sealed off, the fog machine is used to inject a non-toxic theatrical fog through the duct blaster fan and into the duct system. The theatrical fog is pushed out of the leaks in the ductwork, visually demonstrating the location and extent of the duct leaks. Use of a fogger helps crews find hidden leak sites in attics and crawl spaces, and it makes a dramatic presentation for homeowners and builders.
Thank you for watching this video on the duct leakage test. For more information on duct leakage testing or equipment operation, please feel free to contact the Energy Code Coach at 240-514-2694.